Hello there. If you're very new to programming and Golang, this is a tutorial for you. We're going to go through the documentation together. This is a introduction tutorial from the Go official website. So I'll link that in the description. Recommend that you go through it yourself. But to get you started and ease you into it, let's go through this together. Tutorial, create a Go module. In this tutorial, you'll create two modules. The first is a library, which is intended to be imported by other libraries or applications. The second is a caller application, which will use the first. Let's go. So let's just assume that everything's all installed. I'm going to assume you've got Go installed. Make a new directory, Go create module. Go mod init. So we need to initialize this, go mod init. You can kind of do it however you want. In Go, the normal way of doing it is if this is something that other people are going to have access to, you'll give the URL here. So like a GitHub URL or something like that. I'm just going to use my channel name. You can use whatever you want. Great, so now we have it. If we take a look, we've got this Go mod file here. This is what it creates. It's got our module name here and our version of Go. This is the minimum version of Go that is required to run it. I'm not too sure how that works in practice. If you're on a lower version of Go, will it not compile? That's possible. But yeah, all I know is that this matches my current version of Go. So far, the file includes only the name of the module and the Go version your code supports. But as you add dependencies, the Go mod file will list the versions your code depends on. Kind of similar to the requirements.txt file in Python for pip or your any of those npm JavaScript package manager stuff. Okay, so in your text editor, create a file in which to write your code and call it greetings.go. Greetings.go. Paste in the following code into your greetings.go file and save the file. So package greetings, import the pumped package, and here we have a nice description. Hello returns a greeting for the named person. So we've got func hello. It takes name, which is a string, and it returns a string. So return a greeting that embeds the name in a message. Here we have the message. We assign to that variable the pumped, I believe it's pronounced pumped. Sprintf. Here, this is a formatted string where we can put that name variable in there. So hi, the name that we give it, welcome, and that's what it will return. So very basic program so far. This tutorial is actually quite good. It goes into a bit more detail here. So this is the first code for your module. It returns a greeting to any caller that asks for one. You'll write code that calls this function in the next step. In this code, you declare a greetings package to collect related functions. So that this part here, we're declaring the greetings package and we're implementing a hello function. It's this one here. So func hello to return the greeting. So this function takes a name parameter whose type is string, like we just saw. The function also returns a string, again, like we just saw. In Go, a function whose name starts with a capital letter can be called by a function not in the same package. A lot of other languages will make it very explicit as to whether it's a public or a private method. In this case, in Go, this is done using the capital letter here. So by saying func capital H for hello, that means that this is accessible from outside of this package. So in Go, this is known as an exported name. Okay, so here it just illustrates what's happening with that function. So func hello name string. This is the function name, capital H, as we just talked about, takes a string, which we're calling name, and this is the return type. So it's returning a string. So declare a message variable to hold your greeting. Now, here we've got var message string. In the actual program here, it's actually quite different. So here we're using this colon equals. What we're doing here is, now it just describes it in the tutorial. So in Go, the colon equals operator is a shortcut for declaring and initializing a variable in one line. Go uses the value on the right to determine the variable's type. In this case, this function here is going to return a string. So then it automatically knows, okay, this variable here is type string. Now they've got it here doing it in two steps. So here you can declare a variable by saying var, the name of the variable, and then the type of the variable. You can do it that way first. In Go, it will be initialized as 0. So in the case of a string, this will just be an empty string. Depending on the other type, it will be initialized in other ways. For example, an integer would be 0. Message, then this is the second line here. So now that we've declared this variable message, we're assigning the result of this function here to the variable. So use the funct package's sprintf function to create a greeting message. The first argument is a format string, and sprintf substitutes the name parameters value for the %v format verb. Okay, so here you can see within the string here, we've got a %v, and then that's where it will put in that name variable. Return the formatted greeting text to the caller. That's what we're doing here. This function will return that greeting, that message. Let's move on to the next section. Call your code from another module. So now that we have this this greetings module that we've created, now we're going to write code to make calls to the hello function in the module you just wrote. Create a hello directory. Just looking at this, it looks like we do have to actually move our greetings.go file into that greetings directory. Let's do that now. Let's just make sure in our directory, we've got our go.mod file, we've got our greetings.go file. Let's just make a new directory called greetings, and we'll move that greetings.go file into greetings. And then we'll create this hello directory as well. So now we have both the greetings and the hello directories. And then, okay, so now we kind of match this directory structure here. To enable dependency tracking for the code, we need to run go mod init, giving it the name of the module your code will be in. Okay, so I think what we're going to have to do is, I think maybe the go mod file, I think this one here should be part of the greetings package. So let's just move that one in there. So move go.mod into greetings. Let's now that we have this hello directory, let's move into it, and we'll do go mod init. So in this case, we're going to again use the whatever name you wanted to give it here, whatever you gave it for the previous one, and this one we'll just call hello. That's done, and then you can see, yeah, again it's created that go mod file. So now let's create this hello.go file. Hello.go. Paste in this code here. Let's just take a quick look. I know the tutorial will go through this in detail, but let's just take a look. Now, the first thing that's showing up here is we've got an error already. Could not import example.com/greetings, and that's because we've called ours something different. So make sure that this matches whatever you called it. So in my case, I called it whodev/greetings. For whatever reason, it's still showing up as not being able to find that. We'll take a look at that later. For now, just make sure that that matches whatever you gave it. Already we can see that here we have package main. We're importing the thump package again, like last time. Now we're importing our other package, and now we have a main function. I'll go back to the tutorial so that we can go through the description there. In this code, we declare the main package. In Go, code executed as an application must be in a main package. So this is required to get our program started in Go. We then, as we just talked about, we import two packages. So this one here and the thump package gives your code access to functions in those packages. So importing this one here, importing the greetings package, will give us access to that hello function that we've created previously. We can see that we're actually using it here already. So greetings.hello, this greetings here being imported, and now we can use that hello function from that. As you'd remember, this returns a string, and we're assigning that to this message variable here. And then we're just printing it out. Edit the example hello module to use your local example.com greetings module. So for production use, you'd publish the example.com greetings module with its repository with a module path that's reflected its publish location. So like I said before, the kind of convention is to use the location that you'd be able to download that from. So whether it be your GitHub or something like that, that would be replacing that example.com there. For now, we'll just leave it how it is. We'll need to go to go mod edit and edit the example.com hello module to redirect GoTools from its module path, where the module isn't, to the local directory where it is. Okay, let's do that. I mean, I guess that makes sense. That's why it can't find it then, because I guess it's looking for the internet to do that. So let's use this command here. So go mod edit, replace example.com. So again, you're going to have to update this to be whatever you used. Greetings, and we're going to replace that with dot dot, so upper directory and then greetings. Okay, so it added this line here, replace who'd greetings with that there. Okay, interesting. Just kind of curious. It still hasn't fixed this up. So I wonder if we do have a problem with our go mod file. Let's continue on. So from the command prompt in the hello directory, run the go mod tidy. Let me just clear that up. So again, we've run that command. Now we have this line here, go mod tidy. Okay, so it looks like it's found it. Now let's see if that's fixed the error. Now that's fixed it. Okay, so we needed to run go mod tidy. That will go make sure that it's found this and that it works. Okay, good. We've all learned something, especially me. So after the command completes, the hello modules go.mod file should look like this. Okay, cool. Let's take a look. Nice. Okay, yeah, so it's added that in there. The command found the local code in the greetings directory, then added a required directive to specify that example.com/hello requires example.com/greetings. Okay, so the number following the module path is a pseudo version number. Okay, so that's this weird sort of like version 000000100. So it's a generated number used in place of semantic versioning, which the module doesn't have yet. To reference a published module, a go.mod file would typically omit the replace directive and use a required directive with a tagged version number at the end. So we can chuck a little version on there. Again, we don't have this published, so we can't do that yet. Now, at the command prompt in the hello directory, run your code to confirm it works. Let's see our program run. Okay, it works. So congrats, you've written 2 functioning modules. Okay, let's do some error handling. So return and handle an error. Handling errors is an essential feature of solid code. In this section, you add a bit of code to return an error from the greetings module, then handle it in the caller. Okay, so in our greetings go, add the highlighted code below. There's no sense in sending a greeting back if you don't know who to greet. Return an error to the caller if name is empty. Copy the following code into greetings.go and save the file. So let's see what's changed. We've got our package greetings, and instead of just importing the font package, we're also going to import errors. Then we're going to not only return a string, but we're also going to return an error. So we can also update the docs here, the comment, to say if no name was given, turn an error with a message. Then we do a check here. So if name is equal to an empty string, then return that empty string, errors.new empty name. And here, this is what we had before. Let me just copy in those comments there. We also need to make sure that we're returning both the message and also nil. Here, notice that we're returning 2 things in both cases. So in this case, an empty string and the error, and in this case, the message string and nil. I think the documentation will explain this. Let's see, is there any additional information here that we need to know about? Yeah, change the function so that it returns 2 values. So that's what we did here. Your caller will check the second value to see if an error is returned. This is a very Go way of doing it. You'll see this a lot where you run a function and then you check to see, did you get an error back? And if you did, then you can handle the error. We're importing errors here. This is the Go standard library errors package. Then we can make use of its new function here. So errors.new, and then we just give it empty name. So that's the description of what the error is. Empty name. We were not given a name here. So then we add the if statement to check and add nil, meaning no error, as a second value here. Good. Okay. So that's exactly what we did. So now in your hello.go file, handle the error now returned by the hello function along with the non-error value. So we were in hello and then hello.go. Okay, so we've got a bit to add here. We're going to be using this log package in the main function here. It looks like all of this is updated, so there's quite a lot. Okay, I'm going to copy and paste this in just to make things a bit faster, and then we'll go through them here in the dot points. So okay, so let's let's take a look at what we've done here. So we have the log package that we're importing now. And we're just setting it up a little bit here. So configure the log package to print the command name greetings. So we can see that anytime something is logged from here, it's going to have greetings as a prefix without a timestamp or source file information. Okay, so that must be these set flags. I'm not too sure. Flag to disable printing. Oh yeah, the time, source file and line number. So yeah, it looks like setting that to 0 means no timestamps or anything like that, which I think, yeah, maybe in your own time, check out the log package here and see what other flags are available, what you can change that to. So assign both the hello return values, including the error, to variables. So here we've got message and error both being assigned here from greetings.hello. As you saw in the previous file, we're now returning both a string and an error here based on our hello function, sorry. This section here handles the error. We try to assign both of these values here. And if there's an error that's returned, it'll set it in this variable here. So now we just check to see if this variable is not nil, as in there is an error in there, there's something in there, then we'll log out that error. Fatal means the program dies, and that's the error that is passed in. Otherwise, if there's no error, then just print the string that we get assigned here. So, like I said, using the log package's fatal function here, so that will print the error and stop the program. Okay, let's run it and see if it works. So I'll just clear that. We need to go back to the hello directory, go run. Yeah, here we're getting greetings empty name. So you will remember from here, from this log setup, so we import the log function, we set the prefix greetings. So we're seeing that there. And then empty name, that is the error that we passed in back here. So when we create this new error, we're just giving it empty name as the error. I gave mine a capital N because I didn't copy and paste this in. So that's why mine is a capital there, but it should be whatever you've passed in here. Exit status 1 means, yeah, it failed. That's how we handle errors. Now we can, if we go back to our hello file, the hello.go file, and instead of passing in an empty string, here let's just pass in Steve. So now when we go to our hello directory and we run it, now that's returning successfully. So that's an example of it working. Previously, it was returning the error. Okay, let's return a random greeting. So in this section, you'll change the code so that instead of returning a single greeting every time, it'll return one of several predefined greeting messages. To do this, you use a go slice. A slice is like an array, except that its size changes dynamically as you add and remove items. The slice is one of Go's most useful types. So you add a small slice to contain 3 greeting messages. Then you'll have your code return one of the messages randomly. For more on slices, see Go slices in the Go blog. Recommend looking into slices, you'll use them a lot. So in greetings.go, change your code so that it looks like the following. Greetings go. So cd greetings go. Okay, so it looks like we're bringing in the math rand package to handle randomness. And here in our hello function, it looks like with our message here, instead of this string, we're bringing in a new function call, random format. And now we need to create that random format function. So I'll copy in the comments so I don't have to type that out. So rand format returns one of a set of greeting messages. The message is selected at random. But let's actually no, I'll paste this in and then we can just read the dot points. just to avoid doing it twice. So in this code, you add a random format function that returns a randomly selected format for a greeting message. Note that random format starts with a lowercase letter, making it accessible only to code in its own package. In other words, it's not exported. Like we looked at with the hello function here, this one has a capital. This one is accessible from the other hello package. However, this one here is not going to be accessible. So we can't grab this directly by going greetings.random format. One question though, I'm not too sure if that is the case. I'm not too sure if it's actually limited or if it's just a convention. That's something to go out and research on your own. I could be wrong. Maybe it does actually limit it, but yeah, definitely something to look into there. In random format, declare a formats slice with 3 message formats. So that's this here, formats. It's a slice. So here you've got these brackets, these square brackets before string. So we're saying this is a slice of type string. You'll notice if you've done other programming languages before, you'll notice that this is kind of similar to arrays or lists. Golang does have arrays as well, but they're the kind of C style arrays where you need to define exactly how big the array is. The difference in Go between an array and a slice is that here we're not giving it a fixed size. So we're not saying, you know, this is an array of 3 strings. We're saying this is a slice that contains strings, and then we are giving it 3 strings to start off with, but we're not defining that as the size of an array. So when declaring a slice, you omit its size in the brackets. Okay, so yeah, sorry, I probably should have just read this first. So like this tells Go that the size of the array underlying the slice can be dynamically changed, kind of like I just went through. So use the math rand package to generate a random number for selecting an item from the slice. So this is where we're doing this part here. So we've got our slice here with 3 different strings, and they can be accessed by passing in the index of the slice. So 0, 1, 2. And what we're doing here with the random package is getting a random integer. So from between 0 to the length of this, and then returning that. So we'll have 0, 1, 2 will be returned by this random call, and then that's the index that we're using to grab one of these. In hello, call the random format function to get a format for the message you'll return. Then use the format and name value together to create this message. Return the message or an error as you did before. Again, if a string is not passed in, if it's an empty string, then we'll throw this error empty name. We're going to have to change. Well, we would have to change this line in the hello.go file, but we did already do that previously. So yeah, we changed that to Steve. Let's just run it. So in the hello directory, so we'll go into the hello directory here. So where we've got our hello.go file, let's run it. Okay, so hail Steve, well met. Okay, so there's one random thing. Great to see you, Steve. There's another one. Hail Steve, well met. That's the same. There should be one more. Hi Steve, welcome. Okay, there we go. We've hit all 3. Now let's move on. Now we can return greetings for multiple people. So in the last changes you made to your module's code, you add support for getting greetings for multiple people in one request. In other words, you handle a multiple value input, then pair values in that input with a multiple value output. To do this, you need to pass in a set of names to a function that can return a greeting for each of them. But there's a hitch. Changing the hello function's parameter from a single name to a set of names would change the function's signature. If you had already published the example.com/greetings module and users had already written code calling hello, that change would break their program. In this situation, a better choice is to write a new function with a different name. The new function will take multiple parameters. That preserves the old function for backwards compatibility. Okay, so that's a good point there. If we're creating these programs to be used by other people, you might have other people in your team or company or even externally use these things. You don't want to break it for them. You want to make sure that the changes that you make are going to still keep working with their code. So that's a very good point to have here to make it backwards compatible. So it looks like we have, we keep our hello function there as is. So this was in greetings. So we keep our hello function there. Okay, I've switched these around so my head doesn't get in the way. So we have our hello function here, which we keep. We keep the random format function as well. So it looks like that stays exactly the same. Hello function stays exactly the same. So we're not breaking anything that exists already, but we are adding this hellos function in there. So I'll just grab this and copy and paste it in. Okay, so now we have hellos, and then go through the description we have here. Okay, so we add this hellos function here, whose parameter is a slice of names rather than a single name. So here we can see that we're bringing in names. We've got a slice, and then a slice of strings that we're calling names. Also, you change one of its return types from a string to a map. So you can return names mapped to greeting messages. So that's here. We've got a map with string. So this is the key or the index of it, and then string. So this, again, this is allowing us to put those messages that we get into this map and using the name as the kind of key, so we can look those up. But yeah, I think it'll get into that later. We're still returning an error here. So if something goes wrong, make sure that we return an error. Okay, so have new hellos function call the existing hello function. So we still make use of that hello function. This helps to reduce duplication while leaving both functions in place. So here we've got our messages. We make this this map here. So this is going to be just grabbing, just setting it up. We're not assigning anything yet. We need to iterate through the loop here and assigning it. But we are setting up the map. So we are assigning the map to this variable here, this messages variable. And then we can use that in this for loop. Loop through the received slice of names, calling the hello function to get a message for each name. So as part of this function being called, we get the slice of names, and then that's what we're looping through. So for this underscore means that we're not using that variable, and then name in range names. So for all of the names that we're given, let's do this. Does it describe? Yeah. Okay. So just going back up to this one here. So messages. So create a messages map to associate each of the received names as a key. So like I said, that key here is how we're going to look up the names and the greeting that we assign to it with the generated message. So in Go, you initialize a map with the following syntax. So make, and then in brackets, we have map, the key type, and the value type. So make map, the key type, which is string, and the value type, which is also string in this case. You have the hellos function, return this map to the caller. Okay, good. If you want to look up more about maps, please do so. And then loop through the names your function received. So that's where we're in this part here. So checking that each has a non-empty value, then associate a message with each. So we're doing that error check here to make sure that when we call this hello function that we wrote earlier, we're not getting back an error. So making sure that there is actually a name getting passed in. And then, yeah, we assign, if this all passes and there is a name and we get a greeting message back, that gets stored in message. And what we're going to do is save that message in the map that we've created. So we've got messages, name is the key lookup, and then the message is being assigned to that key. So this underscore here you don't need the index. So this is part of the for loop in Go. So this is going to be like 0, 1, 2, 3, 4. So like every time we loop through, we'll get that index, but we don't need it. So when you get something returned that you don't need, you can just use an underscore in Go. Okay, so in your hello Go calling code, pass a slice of names and then print the contents of the names messages map you get back. So let's go do that. So I'll just save this and then we'll bring up our hello.go file and let's pass in a slice. So we continue to set the flags to set up the log that way. And then here, a slice of names, just going to pass these in, just going to copy those in to save time. We can all see what it's doing. Okay, so we've got the names there, and then request. So request greeting messages for the names. So now instead of calling hello, we're calling hellos with all of the names that we've passed in there. And we can do the error handling here. So if error is not nil, then we can log that out. Again, fatal. So we stop the program and log out the error message. If there's no error message, then let's just print out messages. So we're going to get those back here. We can just print it all out together. So we can print the return map of messages to the console. So I'll just close that in hello. Let's do go run and we've got it. So we've got the map here. We've got the name as the key and then the message. So we've got them here. Those two are the same. They're all the same. So it is random. So there's a chance they could be different. I mean, let's run it again. Great to see you. Yeah, okay. So these are random. You can see the first time we've run it, we've got this one. The second time we've run it, we've got another one. Yeah, and then hello is still returning there as well. So you can see in Go, we've just purely just printed out the map, and it's prefixed it with this map and then the square brackets, comma separated. So that's a nice little debugging tool that you might be able to make use of. Obviously you'd want to format it a little bit nicer if this was getting output to a user. You know, you wouldn't want to have a map or whatever, but depending on your application, you know, this could be fine. Okay, let's write a test. Now that you've gotten your code to a stable place, nicely done by the way, thank you. Add a test. Testing your code during development can expose bugs that find their way in as you make changes. Excuse me. Are you laughing at me? So in the greetings directory, create a file called greetings_test.go. Create our greetings_test.go. Ending a file's name with _test.go tells the go test command that this file contains test functions. Let's paste this in and then take a look at what it does. So in this code, we implement test functions in the same package as the code you're testing. So we set the package to greetings, the same package as the code that we're testing. Create two test functions to test the greetings.hello function. Test function names have the form test name, where name says something about the specific test. Okay, so here we've got test and then hello name and then test hello empty. Test functions take a pointer to the testing package's testing.t type. So yeah, so here we're importing testing, right? And then for each test function, we take a pointer to the testing.t function. So in a future video, we'll talk about pointers, but that's this little asterisk thing here. And then testing, so that's the package we're importing, .t, and we're just calling it a little t here. So that's how we can make use of some of the functions that we get with this testing package here. So t.errorf, I think it'll probably go into it later, but that's what that means. So implement two tests. test hello name calls the hello function. So that's this one here. We're calling the hello function. So here it is here. Now, the hello function is part of our greetings package, so we can just call it directly. If the call returns an error, sorry, let me go back to the start. So test hello name calls the hello function, passing a name value with which the function should be able to return a valid response message. So here we're giving it this name here, which is the string. Once, okay, so it looks like we've got some regex, must compile, okay, and then message error. So here we're calling the hello function, and here we're using that regex to make sure that it is being compiled properly. To me, this seems kind of messy. I don't know why they're doing it this way. To have like some regex in here, but I don't know. It's the way they're doing it. So yeah. So if the string that we get back doesn't match the regex here, then we'll throw this error message here. So that's where we're using t.errorf. So if the call returns an error or unexpected response message, one that doesn't include the name that you passed in, you use the t parameters errorf method to print a message to the console. So I guess the reason for the regex is that we're not just getting the name back, we're getting that string of like hello whatever, those random greetings. So we do need to see like, okay, does the name string exist within that? So okay, I understand why regex is being used here. Anytime I see regex, I get scared. It's very confusing to me. I've never been able to memorize all of it. So if the call returns an error or unexpected response, one that doesn't include the name you passed in, use the errorf method to print a message to the console. Okay, then the second test function we have, hello test hello empty, is testing a function with an empty string. This test is designed to confirm that your error handling works. So we know what's supposed to happen if we get an empty string passed in. We're supposed to get that that error message back. So we're just making sure that that happens. So if the call returns a non-empty string or no error, you use the t parameters errorf method to print a message to the console. So we should be getting an error here. So if we're not getting the error back, then we return this error message here, the test fails. Or if we're getting an empty string back in this message here, then or if the message is not an empty string. So if it's returning some kind of value here when we're passing in an empty string, so we shouldn't be getting an empty string back. Then we'll throw this error here. So let's try and run this. So I will close that, and so in the greetings directory, that's where we are now. We can run go test. So go test, and the test should pass, and they do. Good. Okay, so pass. Okay. Greetings, and that's how long it took to test it. So great. Looks like there is a verbose flag that we can set here. So go test -v. Looks like it's just a little bit more verbose where it goes through each test specifically. We don't have any additional information there, so it's just saying these are the tests that passed. Okay, so break the greetings.hello function to view a failing test. The test hello name test function checks the return value for the name you specified as a hello function parameter. To view a failing test result, change the greetings.hello function so that it no longer includes the name. Okay, so let's do that. So if we go to our greetings.go file, And let's just change this so that it no longer returns the name. So we can just remove that there. Then when we run the tests, they fail. So greetings.go, line 18, non-constant format string equal to format sprintf. Okay, that's not the actual test, sorry. So here, yeah. So here, that was not actually compiling. So when Go tries to build the program, it runs through a bunch of checks. And in this case, it didn't compile because we had a sprintf function call, but we're passing nothing else into it. So that was not actually the test failing. That was prior to that. But now if we, okay. So again, this is another sort of thing here. So fumped, imported and not used. So Go does not let you import packages if you don't use them. So here, my IDE will throw the error here, but Go also checks that at compile time. So let's try again, and there we go. Now we have the actual test failing. So these are not the compile errors. This is the test failing now. So fail, test hello name, hello Gladys, fail. Okay, so here we can see that greetings test Go on line 15 has failed. Cool. That's really cool. Okay, so yeah, okay, they just commented that out. We could have made our lives easier and done that. Yeah. Okay, so we can put that back if we want. But yeah, that's okay. That's the test. Yeah, the next step is just to compile and install the application. So I mean, let's just quickly run it. We're not going to go through installing the application. We're just going to go through building the application. So let's do that first of all. So in the hello directory, so we do this where our main actually, sorry, let me just fix what we broke. So in greetings.go, I will just fix up yeah, so this one here, let's make sure we're returning that properly. Oh, yep, sorry, whoops, we need to import some we need to import the pumped package again. Okay, and yeah, so now we can let's go to greetings again. Let's just run test and make sure that we've fixed it. Okay, so now it's passing again. Great. Now let's go into our hello module, our hello package, and so this is where we have our main function, the main package, and this is where we're going to build the application. So we do that by doing go build. And now you'll see we have this hello.exe file. If you're on Linux, it'll look different. If you're on Mac, it'll look different. On Windows, you'll get the exe file. But on Mac and Linux, it's the same. You will get the compiled binary that you can run. So we can run hello.exe here, and our program runs. So very, very basic program. Obviously, we're not taking any inputs or anything like that. We are just doing whatever we have written in our code. But that is essentially how you go through, create the different modules. Create a module with the different packages and call one from the other, write a test. This is all really, really useful stuff. So I'd recommend going through this yourself. Go to the docs, take a look, play around with it, and then start bringing this into your own code.